After years of planning and preparation, NASA is gearing up for its most ambitious mission yet, sending humans to Mars. The mission, set to launch in 2030, will see astronauts travel to the Red Planet to conduct groundbreaking research and explore the possibility of human colonization. But before the astronauts arrive, NASA will be sending a series of robotic missions to Mars to gather crucial data and pave the way for human exploration. One of the key objectives of the mission is to search for signs of past life on Mars, as well as study the planet's geology and climate to better understand its history and potential for sustaining life. The mission will also test new technologies and systems that will be essential for future Mars missions, including advanced life support systems and habitats for long-duration space travel. With each step of the mission, NASA is getting closer to its ultimate goal of sending humans to Mars and making history as the first humans to set foot on another planet. Before we delve further into the Mars mission, let's explore Mars from a historical perspective. This celestial body hanging in our night sky has been a source of intrigue and fascination for as long as humans have turned their gaze upwards. From the ancient Greeks and Romans who named Mars after their god of war, to the countless science fiction authors who have imagined its alien landscapes, Mars has always held a special place in our collective imagination. Yet what do we really know about Mars? Its reddish appearance due to iron oxide or rust on its surface gives it a distinctive color. This has earned it the nickname the Red Planet. Beyond this, our understanding has been shaped by centuries of observation and, more recently, by the brave new world of space exploration. The mysteries of Mars are many. Its thin atmosphere, its extreme temperatures swinging from blisteringly hot to freezing cold, its towering volcanoes and deep canyons, all of these aspects of Mars present us with questions. How did Mars come to be this way? Does it hold any clues to the origins of our own planet? Or the question that has captured our imaginations for decades, could life in some form exist there? Mars exploration. The endeavor to answer these questions has become one of the great scientific pursuits of our time. It's a journey that requires the boldest of human curiosity, the sharpest of scientific minds, and the most cutting edge of technological innovations. And who would be better to lead us on this journey than NASA? Their tireless efforts, their groundbreaking missions, their relentless pursuit of knowledge, all combine to bring us closer to answering these questions, to unraveling the mysteries of Mars. Our journey to uncovering Mars mysteries begins with the efforts of a dedicated team at NASA. The journey to Mars started many years ago with NASA's first missions. In the late 60s and early 70s, NASA launched the Mariner missions, kicking off humanity's quest to understand our mysterious neighbor. Mariners 4, 6, and 7 were flyby missions, taking the first close-up photos of the Red Planet. The Viking missions, launched in the mid-70s, took our exploration a step further. These missions were ambitious. They not only orbited Mars but also landed on its surface. Viking 1 and Viking 2, each consisting of an orbiter and a lander, aimed to capture detailed images and conduct a series of experiments to look for signs of life. While the Vikings didn't find any green Martians, they did make some groundbreaking discoveries. They found that Mars has a thin atmosphere composed mostly of carbon dioxide with traces of nitrogen and argon. They discovered the planet's surface is rich in iron, hence the characteristic red color, and they detected a surprising amount of water vapor in the atmosphere. However, these missions weren't without their challenges. The harsh Martian environment tested the limits of our technology. Dust storms, extreme temperatures, and communication delays posed significant obstacles. But these challenges only fueled our curiosity and determination to explore further. The Mariner and Viking missions were a testament to human ingenuity and the spirit of exploration. They laid the groundwork for understanding Mars's geology, climate, and potential for life. They showed us that Mars, though different from Earth, is a world with its own unique stories to tell. These early missions set the stage for more ambitious explorations. The exploration of Mars took a significant leap with the introduction of rover missions. This new era of exploration began with the Pathfinder mission and its Sojourner rover in 1997. This plucky little pioneer, about the size of a microwave, was the first to trundle across the Martian surface, analyzing rocks and soil, and providing us with our first close-up view of Mars. Next came the twin rovers, Spirit and Opportunity in 2004. Spirit, despite getting stuck in a sand trap, exceeded its planned 90-day mission by several years, unveiling evidence of past water activity. Opportunity, on the other hand, became the longest-running rover, and discovered definitive proof of liquid water on ancient Mars. Then, in 2012, we saw the arrival of the car-sized Curiosity rover, the most technologically advanced rover yet. With its state-of-the-art laboratory, Curiosity was able to identify organic compounds, the building blocks of life, and confirmed that Mars once had conditions suitable for life. They've discovered that Mars, now a frigid desert, was once a world with a thicker atmosphere and liquid water on its surface. A world that could have potentially supported life. In the quest to understand Mars better, NASA launched the Mars Science Laboratory. This mission, a major leap forward in our exploration of the Red Planet, was centered around its primary component, the Curiosity rover. Curiosity's journey started in Gale Crater, an intriguing site with a mountain of layered materials. Over the years, Curiosity has made some groundbreaking discoveries. It found that Mars once had conditions suitable for life. There were signs of an ancient stream bed where water once flowed. Curiosity also detected a seasonal variation of methane in the Martian atmosphere and organic molecules in rock samples. These are the building blocks of life as we know it, adding more fuel to the burning question of whether life could have ever existed on Mars. Curiosity has been monitoring radiation on the Martian surface, vital data for when we eventually send astronauts to Mars. Still roaming the Martian landscape, Curiosity continues to send back invaluable information, helping us piece together the intriguing puzzle that is Mars. The Mars Science Laboratory has truly pushed the boundaries of what we thought possible. And who knows what exciting revelations the future holds as we continue our exploration of the Red Planet. The year 2020 marked a new era in Mars exploration with the launch of the Perseverance rover. This mission, aptly named Mars 2020, was a monumental step forward in our quest to understand the Red Planet. Mars 2020 had a clear and ambitious objective: to seek signs of ancient life and collect samples of rock and regolith, broken rock and soil, for a possible return to Earth. The Perseverance rover, the heart of this mission, was engineered with the most advanced scientific instruments to tackle this task. It's a car-sized, six-wheeled robot equipped with a suite of tools designed for exploration and analysis. These include a drill for collecting rock core and soil samples, cameras for detailed imaging, and instruments for chemical and mineral analysis. Among its myriad of tools, one stands out as particularly revolutionary: MOXIE, or the Mars Oxygen In Situ Resource Utilization Experiment. Mars 2020 also carried a special passenger, the Ingenuity helicopter. This 4-pound rotorcraft made history by achieving powered flight on another planet for the first time. Perseverance's journey on Mars is more than a scientific mission. It's a testament to human ingenuity and our insatiable curiosity to explore the unknown. Each day on Mars, Perseverance travels, takes images, collects data, and sends it back to us here on Earth, helping us piece together the fascinating puzzle that is Mars. Through the eyes of Perseverance, we are exploring terrains never before seen, digging into Mars' past, and paving the way for future human exploration. As we continue to explore Mars, what does the future hold for Mars missions? Let's delve into the next chapters of this cosmic chronicle. The upcoming decade is promising to be an exciting era for Mars exploration, with several missions already on the drawing board. One such venture is NASA's Mars Sample Return mission. This ambitious project aims to bring back samples from the Red Planet, a feat never achieved before. The mission will involve several spacecraft working in concert, including a rover to collect and store samples, a lander to retrieve them, and an orbiter to return them to Earth. The samples will provide invaluable insights into Martian geology and the planet's potential to harbor life, past or present. Then there's the Artemis program, NASA's grand plan to return humans to the Moon by 2025 and use it as a stepping stone for future Mars missions. The program will test new technologies, systems, and operational procedures for human exploration of Mars. In essence, the Moon will serve as a proving ground for Mars. The Artemis program will also introduce the Gateway, a small spaceship that will orbit the Moon and provide astronauts with access to any part of the lunar surface. This spaceship will serve as a model for future Mars transit vehicles. They could also pave the way for human colonization of Mars, a concept that, while still in the realm of science fiction, is inching closer to reality with every successful mission. As we continue to push the boundaries of human knowledge and capability, who knows what secrets we'll unlock about the Red Planet? Only time, perseverance, and our insatiable curiosity will tell. One of the most intriguing questions about Mars is whether it could support life. One of the most compelling pieces of evidence suggesting that life could have existed on Mars is the presence of water. More recently, scientists have discovered signs of liquid water beneath the Martian surface and seasonal flows on its slopes. Life as we know it also needs a source of energy and a supply of carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Interestingly, the Mars Science Laboratory's Curiosity rover has found evidence of all these elements in Martian rocks. The Perseverance rover, part of NASA's Mars 2020 mission, is currently exploring the Jezero crater, a site believed to have been a lake billions of years ago. The quest to find life on Mars is more than just a scientific endeavor. It's a journey that could redefine our understanding of life's existence beyond Earth. The red planet, with its alien terrain and harsh environment, presents a significant hurdle to our exploration endeavors. One of the primary obstacles we face is the technical difficulty of designing and operating machinery that can withstand the Martian elements. Mars is a world of extreme temperatures with an average surface temperature of -80 degrees Fahrenheit. This cold, coupled with a thin atmosphere composed mostly of carbon dioxide, can wreak havoc on sensitive electronics and mechanisms. Mars is also plagued by global dust storms that can last for months, potentially damaging equipment and obscuring solar panels. Then there's the issue of distance. Mars is, on average, about 140 million miles away from Earth. This presents a communication delay that can range from 4 to 24 minutes, making real-time control of rovers and other equipment impossible. Instead, these machines must be semi-autonomous, capable of making decisions and reacting to their environment without immediate input from their operators. But perhaps the most daunting challenge of all is the question of human health in space. Long-duration space travel exposes astronauts to a range of health risks, including muscle atrophy, bone density loss, and exposure to harmful cosmic radiation. There's also the issue of sustainability. For humans to live and work on Mars, we'll need to find a way to produce food, water, and breathable air on a planet that currently offers none of these essentials. This will require innovative solutions and technologies that are still in the early stages of development. And as we continue to innovate and adapt, the dream of setting foot on the Martian surface becomes ever more achievable. Mars exploration has been a powerful driver of technological advancement. The challenges of reaching and studying Mars have necessitated the development of new technologies, from cutting-edge propulsion systems to innovative communication methods, and even advancements in AI and robotics. These technologies, born out of the necessity for survival in the harsh Martian environment, have found their way back to Earth, benefiting our everyday lives. They've improved the efficiency of our industries, enhanced the capabilities of our gadgets, and even contributed to life-saving medical technologies. The quest for Mars has also fostered international collaboration. Nations have come together, setting aside their differences to unlock the secrets of our shared universe. This spirit of cooperation is a testament to the unifying power of exploration, reminding us that we are, first and foremost, citizens of Earth. Moreover, as we continue to explore Mars, we're not only learning about a distant planet, we're learning about our own. By studying Mars's climate and geology, we gain insights into Earth's past, present, and possibly its future, helping us to better understand and protect our home planet. The exploration of Mars continues to shape our future in profound ways. As we look to the horizon, we can see a future where Mars is not just a distant red dot in the night sky, but a new frontier for humanity to explore, and possibly one day, call home. Thank you for watching Time Pilgrimage, and as always, please remember to subscribe, like, and comment. If there is a topic that you would like to explore, please drop a comment.